steroid hormones again, or their abbreviations.
Mineralocorticoid,
Mineralocorticoids.
glucocorticoid, and sex hormones.
Very good. Glucocorticoid, sexy hormones. All right.
Can you use a different pen?
I can try. I just realized you can't see that?
No, not really.
All right.
Everyone that used to write on the wall over here, that was nice and clear.
Yeah. All right, so there are steroid hormones, the ones right off your list. It says steroid. What we are supposed to learn of why that's important is the second part of that question. What does that mean in terms of the hormone's job? So go back to Biology 112. What are steroids made out of? Or what kind of molecule are steroids? What is it?
Lipids.
They're lipid-based. So steroids are made out of lipids, which is another way to say what? Fat. So are they polar or non-polar? They're non-polar. Can someone tell me something around a cell that also is non-polar? Say membrane. Membrane. So they can pass through the membrane. Remember your Biology 112. Things that are lipid soluble can go through a membrane. Things that are large and polar cannot. So lipid soluble hormones can go right through the cell membrane. And where would they go after they go through the membrane?
To the genes.
To the genes. Where are your genes located in this context? In the nucleus. Very good. You remember your 112. So steroids can go directly into a cell and go into the nucleus and change your DNA around. Non-steroids cannot do that because they're not based on fat. So to prove I'm not making this up much, I'm going to show you a picture here of steroid action. No, you don't have to ever draw this. You look at the pictures up. Here's my steroid. There's my fat type molecule. Hey, that's a phospholipid bilayer, right? All right. So it can go through my phospholipid bilayer, aka cell membrane, bypass all that crud you learned in 112, and go right into here. Hey, that's my genes in my nucleus. So steroid molecules can go directly into the nucleus and do something. Right? So they don't have any intermediaries that they need. Right? So I'm going to show you an animation, because I know you love that so, of this process. Right here.
Steroid hormones are not water-soluble. They travel in the blood attached to protein carriers. When steroid hormones arrive at their target cells, they dissociate from their protein carriers and pass through the plasma membrane of the cell.
How can they do that?
Because they're lipids.
Because they're lipid. They're essentially like a membrane. They can just pass in. They don't need anything to get in. They just walk on in.
Some steroid hormones bind to specific receptor proteins in the cytoplasm and then move as a hormone receptor complex into the nucleus.
That's optional. Not all of them have
Other
to do that.
steroids travel directly into the nucleus before encountering their receptor proteins, not shown.
Of course not.
The hormone receptor protein, activated by binding to the hormone, is now able to bind to specific regions of the DNA. These DNA regions are known as the hormone response elements.
I really don't care.
The binding of the hormone receptor complex has a direct effect on the level of transcription at that site. Messenger RNA, mRNA, is produced, which then codes for the synthesis of specific proteins.
Remember that was like 3 weeks of Biology 112 there, right? So take-home message, I give you a steroid hormone. It's going to go right smack in your nucleus of all the cells it can get to. Change your DNA around, and you're going to do something. Right? So let's see, mineralocorticoids. What's it going to do to you if it's mineralocorticoids? It's going to tell your DNA to do what? Deal with salt, right? Glucocorticoids is going to tell your DNA to do stuff with sugar. If it's sexy hormones, it's going to tell them to be sexy, right? But it's going to go directly into your nucleus. So a shortcut way to say all this is called a direct action. So So one way you can say passing directly into my nucleus is say steroids have a direct action, or another way you'll say it is a primary messenger system. Those are all fine. Or you can just skip all that and just write passing through my cell membrane. That's all fine. So if you're taking a steroid, it's directly acting on your nucleus, or it's a primary message, or it passes through the membrane.
Is that 1 degree message or?
Yeah, 1 degree or primary.
Okay.
Either way is fine. All right? So that's what makes steroids so special, is they don't need anything to get into you, in a nutshell. So if this were a non-steroid, what do you think you'd see?
Second messenger.
Yeah, let's find a non-steroid. Here it is. Look at that complexity.
Because
Why is there so much junk on this screen as opposed to steroids?
it needs protein carriers.
It does. It needs something to get into the cell and get to my nucleus. Why can't it go into my cell nucleus directly?
Because it's not a lipid
It's
base.
not a lipid. Very good. So here's my hormone up here. It can't get through the membrane because it's not a lipid. So it has to bind on a receptor. That turns on all this other crud you don't have to know to tell your nucleus what to do. So let's write that over here. So if you're a non-steroid, you cannot enter the cell. Right? You can't do it by yourself. So what do? You bind to cell receptors. Now there are also cell receptors for steroids, but that's not to get them in the cell. Right? So you have to bind to receptors. The receptors, I can't spell receptors, activate enzymes. And where are those enzymes located, you think? Where is that?
On the protein?
In the proteins inside the cell. Those enzymes affect your DNA. So you bind to a receptor, the receptor turns on enzymes, the enzymes change your DNA. So there's these intermediaries. So if you look again on this picture, A is the hormone, B is the receptor, all these other letters are the hormones. Notice ACE, 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 right? Those are the things that are going to turn on my nucleus because I can't go there on my own. Fancy? Fancy stuff, huh? Just some more wording for you. You can write all this, I'm cool. If you're to pick words from over there, this is not direct, obviously, so how would you say this process?
Non-direct.
Non-direct or indirect. So you will see people say this is an indirect system, because I don't go directly, I use enzymes. Or what kind of messenger might it be? We call that a secondary messenger system. I'm not going directly, I knock on the door and then you go in directly. That's a secondary messenger system. Other words you'll see people use, if you look at some of these words here, they also call them a G protein. So if you're reading literature, they'll talk about G proteins. A G protein system. That's another way to say all this goop in the cell. I don't care which one you pick. I know the answer, right? But you can see G proteins, you can say secondary, indirect, all those are fine. Let's watch an animation of this one, because I know you love it so. No sarcasm in my voice? Get the right one here. Okay, where'd my non-steroidal go? I lost my non-steroidal hormone. Hold on. My non-steroidal. I lost my non-steroidal.